Hello everyone. Today we are going to discuss a very important topic in your steel structure, and the topic name is bolted connection in a bracket plate. So why this topic is important? Now reason is if you go through the previous year's questions, previous year's gate questions, you can find out what is bolted connection in a bracket plate. I think everyone knows this. Suppose this is your column and it is connected by a plate and a load is acting. Just assume. So what will be the 3D view in this case? The connection is like this. So this is same the bolted connection. Now why it is important? The reason is if you go through the previous year's gate questions, you can find every alternative year there is 1-2 marks questions from this topic. And what is the real life application? You can see the real life application for bolted connections in a bracket plate is using everywhere. If you go through any railway platform, any steel structure practical problem, take any problem, you can see this is the bracket plate connection has been done by bolting. Sometimes instead of bolting, welding has done. This is the only difference than bolted connection in a bracket plate and welding connection in a bracket plate. Today we are going to discuss only bolted connections in the bracket plate. So let us start a simple case. Suppose take a simple example. This is a column and it has been connected by a bracket plate. This one. So this is your column and this is your bracket plate. Now just assume this is connected by some number of bolts. Let us assume this is connected by 6 number of bolts. Right? So we can see that from this diagram, here this column has been connected with a bracket plate by 6 number of bolts. So like these are the bolts. Right? And a concentrated load is acting at a distance, some distance that we do not know, that is equal to P. Now we can see due to the symmetrically case, this is a symmetrical case, the bolted has been kept similar ways, like then its center of gravity will be here at this point. Now let us assume the distances here, this one, and this one are, these distances are same and same for this case. Let us assume this is your 30 and 40. Now again assume the bolt has diameter equal to 20 mm. So this is your case. This is a simple column which has been connected with a bracket plate and a concentrated load is acting at the free end at some point, not at the free end, it can be at any point on the bracket plate. It is connected by 6 number of bolts, right? And the bolteds are connected like this. And the bolt diameter is 20 mm. So here we have to find out the maximum load carrying capacity in this case. So our task is maximum load by any bolt this one. So maximum load by any bolt, how much? This was the first case, and maximum load P equal to how much? So these are the two cases. Again, we have to find out the maximum load carrying capacity of a bolt, and here the maximum load P, what it can carry out. So first one is easy. This is a simple design strength of any bolt. So suppose if you take first one, maximum load or maximum load carrying capacity on any bolt. So first one, maximum load capacity of a bolt. So this is your first task. So here we all know that there is two cases. First one due to shearing, and second one is due to bearing. Now you can see the column has been connected with the bracket plate, right? Like this, and there is a bolt. So number of shear plane is 1. So we all know that net equal to design equal to net by gamma of MB. So that is equal to 1 by 1.25 into f of ub by root 3 multiplied by n of n into a of nb plus n of s into a of sb nb sb. So this is your case due to shearing. So here if you take the shear plane at the thread positions, because why you are not taking at the shank position? Because if you take the shear at the shank positions, then the area will be more compared to area in the thread. So that's why you are taking the shear plane at the thread positions, and the number of shear plane is acting 1. So from this you can find out easily. For 20 mm diameter, it will come 45.27 kilonewton. So this is the strength, design strength due to shearing. Next one is due to bearing. Again we know that net equal to design equal to net by safety factor of the material. So 1 by 1.25, 2.5 into kb into d into t into f of u, right? So just assume the bracket plate thickness t equal to 10, right? So from that you can find out again kb, assume 1.25, take kb equal to 0.5, generally it has come 20 into 10 into fu. So we are taking Fe410 plate, this one. So from that it will come more than 45.27 kilonewton. Some value will come that is greater than 45.27 kilonewton. Hence, strength of any bolt equal to 45.27 kilonewton, because this is the least of these two cases. So if you take this one due to shearing and due to bearing, there will be two cases. So we will take the lesser one, and that is the strength of any bolt 45.27 kilonewton for this case. So first one we got 45.27 kilonewton, right? Second task is maximum load P equal to how much? Now let us take a broader version. Let us take a larger version of this case. So just assume, take the bolts number 1, number 2, 3, 4, 5 and 6. Right? So there is numbering of the bolts. So let us take bolt 1 in a broader version. So if you take only the bolt cases, right? Bolt 1, 2, 3, 4, 5, 6. Hence, here we can see load is applied at some point at end, this free point. Now again, at this point, the load will act, this load will act, load P will come, and due to this eccentricity, a moment will be generated. So that is equal to P into E, right? We have done one thing in our structural analysis. Everyone knows that suppose there is a diagram and load P is acting at a distance of L, right? So this diagram can be drawn at like this one. Here load P is coming and a moment will come, P into L. This diagram, that is called as force transmission theorem. This diagram is called as, this case is known as force transmission theorem. So this is what we have done. The load is at the free end. We are taking load at the line of action and the applied moment will generate it, and the load, and it will be generated as a moment equal to P into distance. So P equal to E. The eccentricity is E. I think it is clear to everyone. Now, this is your first bolt. So F1, that is equal to load on bolt 1, that is your bolt 1, due to load P. So here we can see that there is two load is acting. A load and force that is equal to P and a moment. So here you can say load on bolt 1. Here load on this case due to applied force. Due to force is equal to simply P by N. N equal to number of bolts. So in this case P by 6, 0.17 into P. Right? Hence it will act this way, F1. So direction of F1 will be like this, and that is the load on bolt 1 due to the force P, this one. Now second is moment. This moment is acting on this case. So again F2 equal to load on bolt 1 due to moment PE. Due to moment PE. Now here, how the moment will act in this case, how the F2 will act and which direction. So here we know that this is the CG of the line of action, right? Simple. So here it will be act F2, nothing but CG of the system and CG of the bolt. Just make it a connection like this. CG of the whole bolted connection and CG of the bolt where we are calculating the F1 and F2. Fine. After that, make a perpendicular angle. Now perpendicular can be which both direction, this way or this way. Here we will take anti-clockwise. So this direction F2 will act. So this is one of the important case to find out where the F2 is acting and which direction F2 is acting. So due to F2, there is a applied moment is acting this side. So whole plate will be try to go this side. That's why just draw the line and make anti-clockwise 90-degree angle for finding out F2 when the load is acting from right side. So this is the first case. Now find out, and it will be written as P into E into R by summation of R square. So if it is R, the distance of CG and the bolt. So this is termed as R. Again, here, this way F1, this is F1 due to load P, and this is your R, find. So this is for bolt 2, CG of the bolted connection and CG of bolt 2 are connected R. Make it an anti-clockwise angle, 90 degree. So that's why F2 is acting also same way, F1 and F2. Similarly, for bolt 3, no problem here, F1, this side, make it a connection CG of the system and CG of bolt 3, right? Again, make a 90 degree opposite side anti-clockwise angle. So if it is clockwise, this side is clockwise, this side is anti-clockwise. So this is 90 degree and here F2 is acting, right? And the angle between F1 and F2 is theta. Similarly, F1 and F2 is theta. This is the angle between F1 and F2, right? So let us take this side also. This side. So here, this side is F1. No problem about it. Now again, anti-clockwise. If I take, this is your clockwise side, this is your clockwise. If you take this side, this is your anti-clockwise. So F2 will be this side with a anti-clockwise perpendicular 90 degree. And the angle between F1 and F2 is always termed as theta. And this theta is smaller angle between F1 and F2, not the larger angle. This is also an angle. We will not take this one. We will take the smaller angle between F1 and F2. Right? Similarly, take this case, bolt 5. So this one is F1 for bolt 5, right? And this is your R. Make it a anti-clockwise 90 degree angle. So in that case, here this side will be F2. So both vector F1 and F2 are acting on the opposite direction. Final one, bolt number 4. So in this case, this side is F1, right? And a anti-clockwise angle, this is clockwise, this side is clockwise, anti-clockwise is this side. So anti-clockwise 90 degree angle will come here, this one, and this one is 90 degree, and this one is termed as F2. Again, smaller angle between these two is termed as theta. This is a smaller angle, theta. This is the case. Bolt 1, bolt 2, 3, 4, 5, 6. All the bolts are undergoing some amount of load due to applied load and due to moment which has been generated. So now next task is you have find out F1 and F2, right? So go through the previous diagram. So you can find out P equal to P. Let us take eccentricity. Let us assume eccentricity is equal to 100. So 100 into R. So here we are taking for bolt 1. For bolt 1, we are taking here. This is your bolt 1. So for here R is equal to how much? That is equal to root of 30 square plus 40 square. So it will come equal to 50. Now summation of R square. So this is R, right? R square plus this is R also, but this is not same. So it is equal to R1. R1 square plus same because it is already given in the problem. Draw the diagram. You can see this is equal to 30 and this is equal to 40. So again it is equal to R square. So for this side, this is your R square. This side, this is your R1 square. And last one, this one is equal to R square. I think it is clear to everyone. Now next is, so P into 100 into This one is 50 divided by R 1, 2, 3, 4. 4 number of R square. So 4 into R means how much? 50 square. Plus R1, there is 2 R1. So 2 into R1 square. So 2 into R1. This is your R1. So R1 means how much? 30. 30 square. Equal to how much? You have to find out. So from my calculation, it is coming 0.4237 into P. Into P. Check the calculation. I think everyone can check the calculation yourself. So we can find out F1 and F2 from the calculation. Now, again, go through the diagram. So this is your F1. You have find out. Okay. So let us erase the diagram. I think it is clear to everyone. It is equal to 0.17 into P. And F2, that is equal to, you have got 0.4237 into P. I think it is clear to everyone. So, bolt 1, F1 equal to 0.17 into P, and Fr this side, and F2 equal to 0.4237 into P, and this is angle theta in between. So this is for bolt 1. Bolt 1. Clear? Now we have to find out the resultant force of F1 and F2. Now from the vector, you can say the resultant force will be this side, Fr. So Fr equal to F1 square plus F2 square plus 2 into F1 F2 into cos theta. Just put the values. F1 means 0.17 into P square plus 0.4237 P square plus 2 into F1 into F2 into cos theta. Now cos theta is how much? Okay, go through the diagram again. If it is theta, check the diagram. If it is theta, this side CG of the system, right? If it is theta, just assume this equal to 90 minus theta. Fine. Why? Because this total angle is 90 degree. So that's why it is 90 degree minus theta. This angle equal to 90 minus theta. So this is 90 minus theta. This is 90 degree. So remaining this angle has to be theta. This angle will be equal to theta. So this one is your theta. So hence, from this case, we can see cos theta equal to 3 by 5. Cos theta equal to 3 by 5. This diagram is, this line is 3, this one is 5. So that's why cos theta equal to 3 by 5. Why? Because we can see from the diagram bolt 1, the angle between is theta, right? And this is your resultant force. If this is theta, this will be 90 minus theta. What is the reason? Because the total angle is theta 90 perpendicular to R, right? So that's why 90 minus theta is this angle. So this is also 90 degree. So we all know that summation of the triangle is 180. 180 minus 90 minus of 90 minus theta. Remaining angle will be theta. So this one. So from here you can see cos theta equal to 3 by 5. So that's why it is equal to 3 by 5 cos theta. And from here you can find out 0.5428 into P. So that is the resultant force on bolt 1. This is your bolt 1. That is the resultant force in this case. 0.5428 into P. Now, just assume, if it is the angle theta is small, if theta is small, less than 90 degree, the resultant force will be more. Now just imagine, if theta value is more than 90 degree, this case, take this case, bolt number 6. So here you can see, theta is greater than 90 degree and less than 180 degree. So from that, resultant will be Fr equal to F1 square plus F2 square plus 2 into F1 into F2 into cos theta. That is your case. This cos theta will come, the value of cos theta will come negative sign. Negative sign. Why? Because theta value is more than 90 and less than 180. So cos of some value will come negative. So from here, it will come less than equal to 0.5428 into P for bolt 6. The reason is simple. It will be converted to minus, right? So that's why we are taking maximum value of P. The maximum value of any resultant force on any bolt. So here you can see bolt 1 and bolt 3 are the critical bolts. Critical bolts means in these cases the resultant force will be maximum. The resultant force due to the first diagram where the bracket plate is there and load P is acting, in that case bolt 1 and bolt 3 will come critical. So that's why 0.5428 into P will equal to the bolt carrying capacity. Bolt carrying capacity equal to 45.27 kilonewton. First problem we have done the bolt carrying capacity. So in this case, load P equal to 83.4 kilonewton. So that is the maximum permissible load in this case. This is your maximum permissible load on bracket. This is one of the most important problem in whole GATE syllabus in steel structure. Bolted connection on a steel structure. I hope everyone got the concept how to find out the maximum force on any bolt in given a bolted steel structure connection. This is the way to find out the maximum force in any bolt in a given system, or find out the maximum applied load or the maximum load which can be applied on the system. So that's all. Thank you everyone.